So our topic for today is all about application of first order differential equation, specifically mixture flow problems. So the general mathematical model for mixture flow problems in differential equation is given that ds ds all over dt, so this one, ds all over dt is equals to rate in minus rate out. So where S in, which is equivalent to amount of solute in all over the volume of solvent in. So the units of this are the following. So some example units of this are the following. It should include pounds per gallon, and then pounds per gallon, and then kilograms per liter, then kilogram per cubic meter. And the next one is V in. So V in is equivalent to volume of solvent in all over time in. So the units of this are the examples of units are the following: gallons per minute, and gallons per minute and liters per minute. And then the second one is S out. S out is equivalent to amount of solute out all over volume of solvent out. So the units are also the same with S in. And then, so pounds per gallon, and then kilograms per liter and kilograms per cubic meter. And also, V out is also equivalent to the volume of solvent out all over time out, and then it has the same units with VN, which is gallon per minute and liters per minute. So, in order to solve the problems in mixture problems, we should first always illustrate it. So, first is I have this one. It's like a container, and then in this one is going to be our S in, and V in. While on this one, on our out, we are going to have S out, and then and also V out. So rate in is equivalent. So rate in is equivalent to S in multiplied by V sub in. And then rate out is equivalent to S out multiplied by V out. So substituting our equation, we will have our general formula. So we will use this formula, equation 2. So we have ds all over dt is equals to S in multiplied by Vn minus S all over V sub O, where V sub O is the initial volume of our container. So initial volume of our container, of the container. And then V out plus T, and then multiplied by V out. So as you can see, if V in is equivalent to V out, then T is equals to 0. So this will cancel out if V in is equal to our V out. So now let's try our example number 1. So we are given that a tank that contains 20 gallons of water in which 3 kilograms of salt has been dissolved completely is to be filled by a hose with water carrying 0.25 kilograms per gallon of salt at a rate of 4 gallons per minute, and then the mixture is then stirred and the solution is being pumped out at the same rate. So we are asked to find the function of salt in the tank at any given time. So first is I'll illustrate our problem. So we will have, so I'll first illustrate it. So our illustration, so this is going to be our out, and this is going to be our in. So, as you can see, we are given that a tank that contains 20 gallons of water. So, initially, we have 20 gallons of water here. And then also, we have initially 3 kilograms of salt that's been dissolved in our container. So, we have 3 kilograms of salt. And then, so this is at time is equals to 0. So, in our so is to be filled by a hose with water carrying 0.25 kilograms per gallon. So our S in is going to be 0.25, sorry, kilogram per gallon. I'll just change my ink first. And then our V in is going to be 4 gallon per minute. And then the mixture is then stirred and the solution is being pumped out at the same rate. So, meaning we don't have S here. So, S out. And then our V out is going to be, so our V out is the same rate with our inlet. So, our inlet is equivalent to 4 gallon per minute. So as you can see from our general formula, which is equivalent to ds over dt is equal to what's is equal to, so our general formula is equivalent to S in multiplied by V in minus the S all over V O plus T multiplied by our V out. As you can see, our V in is equivalent to our V out. So that's equal to 4 gallon per minute. So we have, so then we can therefore conclude that our T is equivalent to 0. So substituting our given, so we will have ds over dt is equivalent to S in times V in. So we will have 0.25 kilogram per gallon multiplied by 4 gallon per minute minus S all over our VO, which is equivalent to our initial volume of our container, which is 20 gallons. So 20 plus T. So our T is equivalent to 0. So I will not write it. And then multiply by our V out. Our V out is equivalent to 4 gallon per minute. So as you can see, this will cancel out. So sorry, we still have kilograms. So we will have ds over dt is equivalent to 1 minus 4 over 20, that's 1 over 5 multiplied by s. And then multiplying both side of the equation by 5, so we will have 5 ds over dt is equivalent to 5 minus s. And then by cross multiplication, we will have ds over, by separation of variables, 5 minus ds all over 5 minus s is equivalent to 1 over 5 dt. Integrating both sides of the equation, so we will have negative ln of 5 minus s is equal to 1 over 5 t plus c. And then taking multiplying both sides of the equation by negative 1. So I'll multiply this one by negative 1. So we will have ln of 5 minus s is equal to negative 1 over 5 t plus c. As you can see, I'll take the exponential of both sides. So we will have, taking the exponential of both sides, so we will have 5 minus s is equivalent to, so you can see this one is also equivalent to e raised to negative 1 over 5t times e raised to c. And this one is also equivalent to c. So we will have c multiplied by exponential of negative 1 over 5t. And then, substituting our initial condition, so we have at time 0, our S is equivalent to 3 kilograms. So substituting S is equals to 3. So we will have 5 minus our S, which is 3, is equal to C multiplied by exponential of negative 1 over 5 times t, which is t is equivalent to 0. So we will have 0. Then this will become 1. So as you can see, the value of c will become 2, is 2. So substituting this one into our equation, so we will have um, 5 minus s is equal to 2 exponential of negative 1 over 5t. And then, by transposing this one to the right side, then transposing this one to the left side, so we will have 5 minus 2 exponential of negative 1 over 5t is equals to s. And then, this also equal to s of t is equal to 5 minus 2 exponential of negative 1 over 5t. So that's the answer. And then, moving forward into our second problem. So our second problem is this. We are given that a tank containing 50 gallons of water, brine containing 2 pounds per gallon of salt, flows into the tank at a rate of 2 gallons per minute, and the mixture, kept uniform by stirring, runs out at the same rate. How long it will take before the quantity of salt in the tank is 50 pounds? So we are asked to find T. So that is what we are looking for. So first is we should put our given. We are given that our S in, first we will illustrate. So our illustration, and then this is going to be our in out, and this is going to be our in. So as you can see, a tank contains 50 gallons of water. So initially we have 50 gallons of water. And then brine containing 2 pounds per gallons of salt. And then and then brine containing 2 pounds per gallon of salt. So we will have 2, and then our S in is equivalent to 2 pounds per gallons. And then flows into the tank at a rate of 2 gallons per minute. So our V in is equal to 2 gallons per minute. And then uh, per minute, and the mixture, kept uniform by stirring, runs out at the same rate. So we have our S out, so that's the unknown. And then we have our V out, which is equivalent to at the same rate. So the same rate meaning 2 gallons per minute. So how long it will take before the quantity of salt in the tank is 50 pounds. So um we are required at T, uh find T find T at 50 pounds is equals to S out. So to solve this one, first we should put our general formula. So our general formula is, I'll just change my ink. So our general formula is ds over dt is equal to S in times V in minus S all over V sub O plus T quantity multiplied by V out. First is, as you can see, our V out is also the same as with our V in. So we have the condition that V in is equals to V out. Therefore, our T is equivalent to 0. So next is we will substitute our given values. So we will have ds over dt is equal to our S in, which is equivalent to 2 pounds per gallon. So 2 pounds per gallon multiplied by V in, which is equivalent to 2 gallons per minute, minus quantity S all over our V sub O, which is the initial volume of our container, is 50 gallons. So 50, and then uh, as you can see, we don't have T. So we will have um, pounds. So this is going to be pounds per gallon multiplied by our V sub out, V out. So our V out is equivalent to 2 gallons per minute. So 2 gallons per minute. You can see that our this one will cancel out. So this one will also cancel out. So we have pounds per minute. So we will have ds over dt is equal to 2 times 2, that's 4, minus this one multiplying this one, the second term. So we will have s multiplied by 2 over 50. So we will have s all over 25. And then multiplying both sides of the equation by 25, so we will have 25 ds over dt is equal to 100 minus s. So separating the variables, so we will have dt, and then I'll put 1 over 25, and then we will have ds all over 100 minus s. Uh-huh. Then taking the integrating both sides of the equation, so we will have ln, so negative ln 100 minus s is equal to 1 over 25 t plus c. Multiplying both sides of the equation by negative 1 over 25, by negative 1, so we will have ln of 100 minus s is equal to negative 1 over 25 t plus c. And then taking the exponential of both sides, so we will have 100 minus s, that's s, is equal to c exponential of negative 1 over 25t. So as you can see, our general function, so we will have s is equal to 100 minus c exponential of negative 1 over 25t. But first, we will substitute our initial condition. We have the initial condition that when t is equals to 0, our the value of our s is equivalent to 0 because we have no given. So substituting this one into this, so we will have 100 minus s, which is equivalent to 100, and then is equal to our c exponential of raised to 0, because negative 1 over 25 times 0 is 0. So this will become 1. So the value of c is 100. So then we will substitute c into our function. So we will have s of t is equivalent to 100 minus our c, which is equivalent to 100, and then exponential of negative 1 over 25t. Factoring 100, so our function will become s of t is equal to 100 quantity 1 minus e raised to negative 1 over 25t. So we are asked that when s is find the time. So we are asked that to find the time required when s is equivalent to 50. So by substituting this one, so we will have 50 is equal to 100 multiplied by 1 minus e raised to negative 1 over 25t. And then solving this one, so we will have dividing both sides by 100. 100. So 100 will cancel out on this side. So we will have 50 over 100 is equal to 1 minus exponential of negative 1 over 25t. So transposing, so we will have 1 half is equal to 1 minus e raised to negative 1 over 25t. And then transposing 1 half to the right side and transposing this one to the left side. So we will have e raised to negative 1 over 25t is equal to 1 minus 1 half. And then taking the ln of both sides, so we will have ln of 1 half and then ln of exponential of negative 1 over 25t. And then ln and e will cancel out, so we will have negative 1 over 25t is equal to ln of 1 half. Solving for t, so we will have multiply this one by negative 25. So we will have t is equivalent to negative 25 ln of 1 half. Solving this, t will become uh 17 17.33 minutes.